RL parallel circuit. This is a RL parallel circuit. The resistor and inductor are connected in parallel. This V phasor is the supply voltage. I phasor is the total current flowing through this circuit. IL phasor is the current flowing through the inductor, and IR phasor is the current flowing through the resistor. Let voltage across this inductor is VL and voltage across this resistor is VR. Now since the inductor and resistor are connected in parallel, so voltage across them will be same. So V is equal to VR is equal to VL. This inductor and resistor will have impedance Z. Now if we apply KCL at this node, so I phasor is equal to IR phasor plus IL phasor. Also according to Ohm's law, V phasor is equal to I phasor into impedance Z. Now from this equation, I phasor is equal to V phasor divided by Z. Now if we replace this I phasor by this value, so this will be V phasor divided by Z is equal to IR phasor plus IL phasor. Now this IR phasor is equal to V phasor divided by R, and this IL phasor is equal to V phasor divided by JXL. This 1 by J represent lagging. Now we can take V phasor common from here. So this V phasor and this V phasor will get cancelled. So what's remain? 1 by Z is equal to 1 by R plus 1 by JXL. The reciprocal of impedance is admittance, and it is represented by capital Y. The unit of admittance is Siemens. The reciprocal of resistance is conductance, and conductance is represented by capital G. Then the reciprocal of reactance is susceptance. Here the reactance is inductive reactance. So 1 upon XL is equal to BL. BL is the inductive susceptance. So here we can write BL. Now this 1 by J is equal to minus J. So here we can replace this 1 by J by minus J. Now Y is equal to G minus JBL. This is a equation in rectangular form. Now phasor diagram. Since the voltage across inductor and resistor is same, so we can take voltage as a reference. The IR will be in phase with this voltage, and this IL will lag the current. This IL will lag the voltage by 90 degree. So this IL is lagging voltage by 90 degree. So the resultant of this IL and this IR will be this current I phasor. Now AB is equal to CD. So we can replace this line by IL. So this will be IL. Now from phasor diagram, we can draw current triangle. In case of current triangle, the values of all sides of triangle will be in current form. So this will be current flowing through the resistor, this will be current flowing through the inductor, and this will be total current. Now if we apply Pythagoras theorem to this right angle triangle, then hypotenuse square is equal to opposite side square plus adjacent side square. So here this will be I square is equal to IR square plus IL square. So from this I is equal to under root of IR square plus IL square. Now according to the formula of trigonometry, tan phi is equal to opposite side upon adjacent side. So this is the opposite side and this is the adjacent side. So opposite side is IL. This IL, the direction of this IL is in y-axis in downward direction. So that's why this will be minus. Adjacent side is IR. So this is IR. So therefore tan phi is equal to minus IL by IR. Also power factor is equal to cos phi, and this will be lagging, and cos phi is equal to adjacent side upon hypotenuse. So adjacent side is IR and hypotenuse is this I. So therefore cos phi is equal to IR divided by I. Now if we divide all the sides of this current triangle by applied voltage V, so this will be a admittance triangle. So this will be conductance G, this will be inductive susceptance BL, and this will be admittance Y. Now again this is a right angle triangle. So using Pythagoras theorem, y square is equal to G square plus BL square. So from this, y is equal to under root of G square plus BL square. Now again tan phi is equal to opposite upon adjacent. So here opposite is BL. Again this BL or inductive susceptance is in the direction of y-axis in downward direction. So this will be minus. So here minus divided by adjacent side. So adjacent side is G, that is conductance. So therefore tan phi is equal to minus BL by G. Now power factor. Power factor is equal to cos phi, and cos phi is equal to adjacent upon hypotenuse. So here adjacent is G and hypotenuse is Y. So therefore cos phi is equal to G by Y. Now power triangle. So this is a power triangle. This S represent apparent power, this P represent true power or real power or active power, this QL represent reactive power, this L represent inductive reactive power. Now again we can apply Pythagoras theorem here. So S square is equal to P square plus QL square. Now from this S is equal to under root of P square plus QL square. Then tan phi is equal to minus QL divided by P. Tan phi is equal to opposite upon adjacent. So opposite side is this QL and adjacent side is this P. Again the direction of this QL is in y-axis direction, in downward direction. So this will be minus. And power factor cos phi is equal to adjacent upon hypotenuse. So adjacent is this active power or real power divided by apparent power. So cos phi is equal to P by S.